We're going to do some word problem applications. We're going to model real world situations algebraically. Um, the examples that we do today, you may say, well, those aren't really uh, those aren't really good real world examples. We're a little bit limited, folks. We're doing college algebra. We're not doing differential equations. We're not doing calculus 3. We're not doing operations research. So we have to pick problems that we can understand and model. So before you say, I'll never be a farmer who's making a pen, uh, just realize we're trying to do this to build skills so you can do tougher problems some other day. Second of all, I've had many times in my life where actually most time farmers have come to me with a word problem, and a lot of times it involves a couple pulleys on an axle, and they're different radius, and they want to know how fast, the end result is turning, or what pulley to purchase for an engine. The other thing that they ask is, they've got a shape that they're storing corn in or soybeans in. They want to know how to calculate the area, or if they're adding to it at what rate, how the pile is changing. Those are all questions that get asked. I'm excited when they do. Usually happens a couple times a year. So, any farmers in here? One? What do you farm? Corn and beans. Very good. Good for you. So, lots of problems like that. We'll see if you guys build a fence or something like that. We'll start out like this. Also, as you see the four boxes, I mentioned to you before that when I was doing my graduate work, I studied graphic organizers and their impact on higher level secondary mathematics students. And if I just open this up real quick, see how that happens here. Okay, so a farmer is making a pen out of 480 yards of fence. He will be dividing the pen into three sections that are all equal in size. What dimension should he make the pen to maximize the area? Now, the fact is, it doesn't say what shape pen we're going to start with, but we are going to make a rectangle. Some people say that they would rather make a circle. I get that, but the circle does make a larger area. But let's say that you have, I don't know, a barn, and you have, I don't know, fence, whatever, and you want to use up that space to build a pen. Well, you're not going to make a circular pen because then this area kind of gets wasted, doesn't it? So even though your pen might have more area in it than my rectangular pen, you've wasted other area as well. So uh, if we can stop having that discussion, that'd be great. So, but it is a great idea that you do have a circular pen because that does create more area. However, it's just generally not very applicable to what you're using it for. So I think we've covered that. All right. So we have 480 yards of fencing divided into three sections. So going to need two lines down the middle, and they are all equal in size. Done my best to show that. So the first step is to model the problem. We draw a box, or we draw our four boxes, and one we draw a picture. The question is, what dimension should he make the pen to maximize the area? So that's my objective. That's what's kind of driving this overall function or this overall problem. I want to maximize the area. So over in this box, this is kind of where the aha moment happens. This is where the kind of tough work occurs. All the other boxes are pretty straightforward. But I need to write some expressions and be able to relate them to one another. So area is what? What do you want to call it? Space times height or length times width? Good. So I'm going to go back to my box. I'm going to call this length. I'm going to call this length. This is width. And I'm going to call each one of these width as well. There's another critical piece of information that we're given in this problem that we got to use. What is that? 480. So can I write an equation that involves the 480? 2L plus 4W equals 480. Good. Because I have four spaces that are going to be used to create the three different pens. Okay. So what I can do now is I want to solve for one of the variables. I want to write a function for area because my goal is to maximize area. In order to do that, I need one variable, not two. So I'm going to solve for L. 2L is equal to 480 minus 4W. Divide by 2, and we've got L is equal to 240 minus 2W. So I can take that and plug it in right there for L. Instead of equation, this should really say function, but a function is an equation as well. I now have a function for area. Area in terms of what variable? What is the variable being used? Yes. Yes. Um, so this is an expression that is going to calculate uh, how much fencing I'm using. So I am restricted to only having 480 yards of fence. Well, I have to use 4 strips here, so that's 4 W's. I have to use 2 strips here, those are 2 L's, so that total amount will add all the way up to 480. It's for the area formula that I'm multiplying. So this is, I would call it perimeter. I guess it is perimeter, but you're also adding up the inside sections. And perimeter, we would add everything else. Okay. So area in terms of what's our variable that we're using now? We're using W. We solved for L, but the variable that's going to be in use is W. So area in terms of W is, we have 240 minus 2W times W. So I just did that substitution. In other words, the area in terms of width is equal to 240W minus 2W squared. And again, our goal is to maximize area. Think about it, folks. What kind of shape does that make? Right side up or upside down? If it's upside down, does it have a maximum or a minimum? It has a maximum. And at what point does the maximum occur? What's that called? The vertex. It will have a location of W and A of W. W being the width, A of W being the area at that given width. How do I find the vertex using negative B divided by 2A? So negative B would be negative 240. Divided by 2 times A would be negative 4. Divide those and you get 60. Now, we could plug it back in to find the y value, but maybe we don't need to do that. Look at what the question is asking. It says, what dimension should he make the pen to maximize the area? Well, I already know that the width should be 60. How would I figure out what the length should be? Plug it in here. Length is 240 minus 2 times 60, so that would be 120. So here, end result is 60 yards by 120 yards. Um, because I'm wondering what the length is, and this says length is. If you, Claire, chose to plug it into here and solve, you would get the same solution, but they are the same equations. So, okay, so the kind of most important box I would say is the second one right here, isn't it? That's where kind of all the magic comes together. So I'm going to try to show you enough examples so you can get that. However, the problems in your assignment might be similar, but they might not be exactly the same. So you might have to come across that a little bit on your own. And it doesn't necessarily occur easily all the time. You're going to have to work for it. So let's try 4 examples here. It says find the function that models the real life situation. So we're not going to set up the entire problem. We're just going to try to set up box number 2. I'll do the first one, you guys do B and C, and then we'll do D together. The sum of 2 numbers is 24. Can you give me an expression for that? X plus Y is 24. Good. It says find a function that models their product in terms of X, one of the numbers. So product. Product would be X times Y. Now, We don't want a function that deals with two variables. We want one that has one variable, namely x. So what I do is I subtract x. I get y is equal to 24 minus x. I'm going to take that, I'm going to substitute it in for y. And I get the product in terms of x is equal to x times 24 minus x. Okay, there you go. Why don't you try B and C on your own and see if you can come up with those. B, a lot of people got during third hour. Not many people got C. Give it your best shot. We'll go over it together. Okay, here we go. A picture is 8 inches longer than it is wide. So what that means is length is equal to the width plus 8. It says find a function that models the area of the picture. So area is equal to length times width. I can simply take that and plug it in right there. So the area in terms of width is equal to W plus 8 times W. If you'd like to write that as W squared plus 8W, that's fine as well. Um, it does only because it says it wants it in terms of width. If you wrote uh, if you wrote L's, it would need to be L minus 8. Okay, a rectangle has an area of 40, so that means that 40 is equal to length times width. Fair enough? Find a function that models its perimeter. Well, perimeter is equal to 2 times L plus 2 times W. So it says in terms of one of its sides, I could choose to use L or W. Do I end up writing a function that's A equals or P equals? P, because it says models perimeter. So I need to solve here. I'm going to divide both sides by, I'm going to choose to divide by W. And so I get 40 over W is equal to L. So perimeter is equal to, what's 2 times 40? 80 over W plus 2W. So that would be your perimeter in terms of width is 80 over W plus 2W in terms of width. So maybe that's not as intuitive, but the length of one of its sides. So whether that, yep. And you'll be able to do that either way. I mean, if you wrote 80 over L plus 2L, that's fine because it's one of its sides. Don't worry, I'm not going to be critical there. Okay, and then the last one, a rectangular box has a square base with the height 3 times more than the depth. So I'm going to draw a box that has a square base to the best of my ability. And there we go. And what do we know about its base? It's a square. So that means if this is x, then what is this? X. What is the height? 3x. Find a function that models the volume. Well, the volume is equal to length times width times height. So if I multiply all those together, what do I get? 3x cubed. How's that? Is that okay? Okay, so you've seen 4 examples now. You've seen one where we did the problem all the way through. You've seen 4 where we just simply model the problem. Now we're going to see 3 more problems all the way through so we can come up with good answers. And this will help you do your assignment for today. So we're going to skip section 3, and we're going to do problems 4, 5, and 6. We go back to a farmer. We're going to change the problem just a little bit. Farmer builds a fence against the barn. barn. Thus, he doesn't need any fencing against the barn. He's very he's looking to save some cost. The resourceful guy, huh? So, what dimensions, if he has 320 feet of fencing, what dimension should he make the fence to maximize the area? So again, what is the objective? What's driving the problem? Maximizing area. So area is length times width. I'll call this width. I'll call this width. I'll call this length. Now what? 320 equals what? 2W plus L. Where 320 minus 2W is equal to L. So your L's are over here. That'll be fine. So we're going to take that, I'm going to plug it in for L. So now my equation is going, or my function is going to be area in terms of what variable? W is equal to 320 minus 2W times W, or 320W minus 2W squared. What shape does that make? Parabola writes it up or upside down? Looking for the vertex, which would happen at WA of W. And how do I find the vertex? Negative B divided by 2A, so negative 320 divided by negative 4 is 80. So I have 80 is equal to W. Now, Claire, you chose L to be this spot, right? If you did, then you would just label that as, 80 would be, it comes out the same. All right, so then the question is, if that's 80, what's L? Plug it back into here, and you get 160. So our final answer, because it says what dimensions, our final answer is going to be, let's see, we're in feet. So 80 feet by 160 feet. What about the boxes? Does it help keep your work organized? Otherwise, you just kind of wonder, where should I go next? And I tell people, they're like, I don't know where to start. Yeah, you do. Yeah, you do. You know to draw a picture. Like, well, I don't know what to do yet next. Yeah, you do. You know the formula for area. Now, you might not be able to get this substitution piece, but at least you know that. So then you can start to kind of struggle and wrestle through that. Once you get there, write the function and solve. You know those pieces. So this is the transition from the second to the third box is really the only hang up that people have. And so that's what we want to work through, okay? And that's what I find works for people. We're doing something in calculus right now, and let me see if I can even show it. And they do it all the time. They don't. I'm trying to get them to actually stop, but they don't want me to. Here we are. We're doing something called, we're trying to find the derivative of the square root of z minus 1 over z plus 1. In order to do that, we draw boxes to organize our work because that's just the best way for us to do it. So it does help, and we will continue to use those type of pieces as we move forward. So we move to here. Problem number 5. Box with an open top is to be constructed from a rectangular piece of cardboard with dimensions 18 by 10 inches by cutting square corner from each corner and folding the sides up. Remember when we did this in class? And some of you made fun of my little diagram, or I actually cut some pieces of paper off, right? I folded it up. You didn't think it was much of a box, though. It's okay. I cried that night. I'm ready to move on. Sticks and stones may break my bones, but words do hurt, though, don't they? All right, here we go. Model. I guess I should draw a piece of cardboard that measures 10 by 18. What am I going to do to it? Take off the corners. What shape do I make to take off the corners? What do those squares measure? Doesn't say, so we'll call it x by x. How's that? What is the formula that's driving this problem? What's my objective? Maximize the volume. Largest volume. Volume equals length times width times height. So what's the length after I cut off the corners? You're so smart. So proud of you. What's the width? What's the height? X. When you fold it up, it's going to be x units tall. So I have a function for volume in terms of the variable x. Let's multiply it out. What's negative 2x times negative 2x? And multiply by x, then at the end would be 4x to the third. We'll do our outside and inside terms. I have negative 36x and negative 20x makes negative 56. Multiplied by the x would be x squared. And then 18 times 10 would give me 180 times x would be 180x. What's different about this function compared to the previous ones that we've seen? It's cubic. So it has a shape like this. First of all, what's the x or what's the y-intercept? 0. So it looks something like this, okay? And we're trying to find the maximum. The local maximum is what we're trying to locate. We can't, there's no formula, folks. We don't know calculus yet. If we did, we could find this. It wouldn't be a problem. But we don't have a formula like negative b over 2a. So therefore, what we have to do is we have to use our graphing technology. We have to use our calculator. And we want to find that spot. I'm going to take out my calculator. And y equals, let's see, we've got 4x squared minus 50, oh, cube, thank you. Minus 56x squared plus 180x. I better go to the window because we'll graph this and it won't even look right. You'll be wondering, what am I looking at? We talked about this yesterday. We need to find a reasonable window. Think about it, folks. If you're cutting x units off, what's the biggest x value that you could have? How about 5? If I cut 5 off from each side here, that whole side would be gone, wouldn't it? But the fact is would you agree that I for sure can't cut 20 off? I mean, that's just absolutely stupid, right? So I'm going to set my minimum to -5. I'm going to go my maximum all the way up to 20. And that way, I'll for sure see everything I need to see. I don't need to go to 100. You know, we know that it should be between 0 and 5. And then let's look at the y value. What does the y value represent in this problem? Starts with a V, volume. So what would be one of the volumes you could come up with? Is it going to be in the tens? Is it going to be in the hundreds? Is it going to be in thousands? Let's check. Let's just try something. Let's cut off a certain size. What do you want to cut off? 2? Okay. So if we cut off 2, my height will be 2. What will be this width? 6. Very good. And what would be my length? 14. So that'll be 12 times 14, which is like, I don't know, 168. Okay. So it looks like we're in the hundreds. So I'll set my y max to 500, and that will for sure be enough for me to see everything I need to see. Okay. So I just was trying to figure out a reasonable graph. And can I see the maximum by looking at this now? Yeah, I can. So I don't have to struggle to try to see my graph. I think about the problem and I go to work. Okay. You should maybe wake them up, Joe. You just tell me you can rewatch a video later on. So let's say you have lunch And all of a sudden, so what he's doing though to really inhibit himself, excited about the lesson. So okay, so we've got this. What do I do now? What do I press? Second, calculate, and what am I calculating? Number 4, the maximum, and I need to go to left bound. Oh, I can't even see where I am. See, and now I'm angry. I don't like this. So I'm going to window, and I'm going to change my minimum instead of -10, make it -500. That way I can see better, because I don't like it when I can't see stuff. So now I go second, calculate, and I do the maximum, number 4, and now I can see better. Get over there. Enter, enter, enter. Yo, Uh, local. Yes, maximum going up, but that would be if we cut something too large off. So you look at our cuts. Could you cut something that's 20? No, it would give you negative dimensions, and that's what results. But we know that we can't have negative dimensions. But mathematics says, what's wrong with having negative width and height? Well, it's impossible in our world. See, our world has limitations. Math doesn't. You like that? There's 2 cents for you. All right. Okay. So the x value is 2.06 and the y value is 168.12. You tell me which one of these am I interested in for the answer. What does the question ask? Question says find the largest volume. This is the volume. So 168.12 inches cubed. Now, yeah, I would like to know that I should cut a 2.06 inch by 2.06 inch square off. But the largest volume is 168.12. That way, if I know I'm trying to fit a fruit cake or something in the box, I know whether it's going to fit or whether I'm going to have to get a different one. Okay. It's that time of year, right? Fruit cake. Yeah, I agree. Disgusting. Who makes them? All right. Last example. Okay. All right. Find the dimensions that give the largest area for a rectangle whose base is on the x-axis and whose corners are on the parabola 12 minus 3x squared. Oh, boy. This is a parabola. I factored out a 3. Do you know what the parabola looks like? Is it right side up or upside down? It's upside down. It goes up through 12, right? And where does it cross the x-axis? 4 minus x squared, folks. Factor. 2 and -2. Thank you. That's 12 up there. Okay. So I'm going to draw a rectangle where its base is on the x-axis, and then its height will be determined that way. So I'm trying to calculate area. Area, again, is length times width. Now, this is where you got to, let's see if you could get the aha moment here. We'll call the length on the bottom and the width on the top, okay? What is the length? What is the base? Hint, look at the coordinate. What's the length of the base? No, 4 is the distance from here to here. It's less than 4, isn't it? Give me it in terms of x. How far is it to get from here to here? X, right? From here to here is x. That's your x value, right? How far is it to get from here to here? X. So x plus x is 2x. Length is 2x. What's my width or my height? What's that other dimension? Y. Very good. Y. I'm glad you asked. 2x times y. Okay. All right. Oh no, I don't want 2 variables. I want 1. If only I had something to put in for y. So my length is 2x, and the y coordinate gives me my height. If only I had something to plug in for y. You see, this coordinate y equals 12 minus 3x squared, the height is, I mean, let's say that we went over 1 unit. The base would be 2, and the height would be, well, 12 minus 3 is 9. You would plug it in there to get the height, wouldn't you? So we could replace this y value with 12 minus 3x squared. That's going to go in right there. Well, the width is that dimension. Yep, the width is y. Yep. So I have area in terms of what variable? No, x is equal to 2x times 12 minus 3x squared. Distribute 24x minus 6x to the third. Uh-oh, it's another cubic. And this time it's upside down. And we will go through the bell today if we need to. We're almost done. So I'm looking for this spot, right? Let's think about our x values. I can only solve this using a calculator. X values, what's the biggest that x could be? 2. So I'm just going to make it 5. I'm going to plug this function in my calculator. Y equals, and we got 24x minus 6x to the third. Delete, 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 delete. And if I go into my window, if I go up to positive 5, that will be more than plenty for my x values. The y value represents the area. So just think about it. If we went over 1, what would be the length of the base? 2. And if we plugged in 1 to get the height, we would get 9. So are we talking about values for the area that are in the tens, the hundreds, the thousands? The tens. So if I set my y minimum to say negative 100 and the y max to positive 100, I'm sure I'll probably see the entire graph. Let's try it and see. Do you see the entire graph? Do you see the maximum? How do we calculate it? So I can calculate, and we go to maximum, and I make sure that I'm to the left, and now I move to the right. And that happens at 1.15 and 18.47. Oh, whoops, I'm sorry. It's a negative 6x to the third, right? See the minus 6x to the third? I'm sorry, I messed that up. I should have drawn it like this. I just forgot. I was thinking ahead, sorry. So the maximum occurs at that 1.15, 18.47. What does the question ask? Dimensions. If x is 1.15, what is the length of the base? 2.3. It's twice that, right? And then how would I find the height? Plug in 1.15 to your function. And if we plug that in, because that generates the height, you guys told me that, 12 minus 3 times 1.15 squared, enter, and I get 8.03. Those are my dimensions. Not easy, huh? But calculus is definitely more difficult. We're in the business of trying to prepare you for calculus, and you're encountered these same type of problems in calc. We got to see them now so that next year you don't freak out when you see them. Okay. So your assignment, it looks bad, but it's not. There's these 9 problems, but you choose 5. Now, I want to be clear. If this class is too easy for you and you're getting bored, make sure you choose the 5 harder problems. There's a couple problems on there that only a few people have gotten over the course of the years that they struggle with. But it's your choice. It doesn't mean it doesn't mean 20 is the easiest one. You read them and you decide which one to start on. You're not gonna get a new assignment tomorrow. We're just gonna finish off the notes tomorrow. Your assignment will still be to choose 5 of those. But make sure you're detailed in your work. Make sure I can read your writing. Spend some time with the handwriting to make sure we're good to go. And choose 5. If you get done with the 5, you're like, oh, I want to try a 6. Go ahead, try a 6. Go to the back of the book. Find the hardest problem you can and try it. Which one? Is that mean we're out? Are we out? Are there no bells right now? Okay, we're out. Have a good day, folks. You'll have a little bit of work time tomorrow.